Thank you for being here with us. I'm Elisa, and we will bring you on a climate trip between Finland and Italy. You maybe ask yourself, why Finland and Italy? So they are the countries we live in, but also there are good case studies for climate visualization because they have so different climate. So if we visualize their climate data, we get visualization that are easy to interpret with high contrast. And we will start with a brief theoretical introduction about climate data. And after that, we will code together with a Jupyter notebook that you can, if you want to follow along, you can download the Jupyter notebook. In the folder, you will find also the HTML version if you don't want to run the code, and also the data set, because climate data is multidimensional, they are large. So we will show you how to download the data through the API, but you need to register to get the token. So just to make things faster, we provided the data we will use for you. So did you have enough time to get the URL? Great. So we can start by defining with some definition. What is weather? So when we talk about weather, it means what is now outside the window outside. So what is the weather now or this week? So it works on a time span of days or hours. If we talk about climate variability, we speak about differences and variability in weather in the time span of seasons, of years. For example, is this summer warmer or colder than last summer? But if we talk about climate change, so we see the changes in a time span of decades or centuries. So when we talk about global warming, this is what we talk about, the climate change. So how do we monitor the weather and the climate? So the global climate observing system has defined the essential climate variables. There are in total 55 variables. Here you see some examples that define there are physical, chemical, and biological variables that define the Earth climate and weather. So we saw how to store the weather and climate. Where does data come from? So there are three main data sources for climate variables. Observation are real measurements. For example, is the data that comes from weather stations. For example, temperature, humidity, precipitations, snow depth, and also satellite measurements that can get data from broader areas. Ocean buoys get data from water and oceans. Reanalysis are data that takes historical observation, but they fill the gaps in this data set thanks to statistical models. So the analysis, they are complete data sets that we can use to analyze past weather. The data sets that we will use later are reanalysis of historical observations. Climate models, they don't only tell us what is past, but they also make prediction about the future. Marina will talk us more about climate models.
Yeah. So analyzing climate data requires that we have some familiarity on how our Earth is geographically mapped. So we need to refresh some knowledge about the basic of a geographical coordinate system. We can imagine our planet has a a globe with drawing lines from the North Pole to the South Pole at regular intervals. And these lines are named meridians and are measured with a constant value for each line, that is the longitude. And similarly, we have the horizontal line from east to west that are the parallels, and the measure related to them is the latitude. Both longitude and latitude are measures in degree. And why they are useful? They are useful since if we want to select an area of interest to analyze the climate data in this area, or simply select a specific location, we need to know the coordinates. And this helps us to filter the data. But we even have to consider another dimension, that is the height, since climate data can be measured at different level of atmospheres, or even pressure if we think about the oceans. And the last variable to consider is the dimension, to consider is the time, since climate data evolve a long time. So we have a sort of grid made by cells, and usually the measure is referred to the center of each cell. So as we have just seen, this data, the climate data, are multidimensional, is complex, and they usually have relevant size. So we need specific formats of file to store them, and even to make them accessible in a quick and efficient way. One of these formats is the NetCDF, that is the one we will use today. And it stores the data according to their dimension, the coordinates, and the attributes, that is another name for the metadata, the information about the data. Our sources today will be the Copernicus ecosystem. Copernicus is a project run by the European Commission and the European Center for Medium and Long-Term Weather Forecast. It is an ecosystem since it has many platforms, and in each of these platforms we can find a variety of data, climate data based on observation, reanalysis, forecast, projections, and so each of these platforms needs time to be explored. Today we will use a dataset from the Climate Data Store, that is one of the most used, and one from the Cross Data Store. From this dataset, we will analyze two variables, the temperature and the precipitation, since these two variables have a high impact on the quality of our lives, on the economic condition, and even to the environment. So last time to download the notebook and the data if we want to run the code. And since I see that someone take picture of the slide, I want to say that we can share even the slide in the same folder at the end of the presentation. So I give the floor to Elisa for the first part.
Okay. But it's totally fine if you just follow the talk. But okay. So we can start with the coding. So here we import some libraries. Some I think have. Is it big enough? Easy to read, or should I? Okay, great. Yes, let's start with importing some libraries. I guess Matplotlib, Pandas, and NumPy are pretty well known. So Matplotlib is for basic plotting, visualizations, Pandas for data manipulation, NumPy is for scientific computing. Xarray is it extends NumPy to work with multi-dimensional label data and with NetCDF files that Marina explained before. GeoPandas extends Pandas to work with spatial data. And the CDS API, it's the API we will use to download data from Copernicus. So here you find the code to download data from the Copernicus API. I can show where the data comes from. Here you find the link in the notebook. But this is the data we will use. This is some gridded daily data from Europe, all Europe, from 1950 to 2024. And we will take the mean temperature. So in the Copernicus Climate Data Store website, you can just put what you need. We take mean temperature, the grid resolution at 0.25. You can get also a smaller resolution, all the period. And here you can get the API request. So if we go back to the notebook, we already have the data. So we don't run that method. So to read the NC file, is a NetCDF extension, we use X-array method, open dataset. And we can print, with the display method, we can see how the data looks like. So we have as coordinates the latitude, the longitude, the time. And the data variables that we choose is, here is called TG, is the mean temperature. As we see, okay, we have, the time is, as I said, is 1950, 2024. This is why we have so many items in the time dimension. It's daily data. Then we get we get the boundaries, the spatial data, the boundaries of Europe, of the countries in Europe. We get them from this URL, from the site Natural Earth Data. And we read it with GeoPandas read file directly from the URL. And we get only the countries, we filter it getting just Italy and Finland boundaries. And we plot really simply with matplotlib method just to check, is this right? I think they look like Finland and Italy, so it's fine. And then here we separate Italy and Finland into individual geodata frames. And we get the bounding box for each country. The bounding box, they are the coordinates, so the latitude and longitude in which the countries are retained. So now what we need to get, okay, we have the boundaries of both countries. We have the shape of the countries, and we have a data set for all European countries. So now we need to extract from this data set only Finland and Italy. So we do it with the X-arrays cell method. So we slice the data, we insert the latitude and the longitudes of the countries, and we get the data for Italy and Finland. Am I going too fast? Or? Okay. Here we also check, because the shape file is in the same coordinate system as the Copernicus data, because if the coordinate system would be different, we need to convert it. But in this case, I go back. It's in VGS84. The coordinate, because the data is now only, they are not, the coordinates are only numbers. To the coordinate system associate these numbers to a specific point on the Earth. So here is just to check that we get the same coordinate system. So they look at the climate data coordinates and the bounds we got before. They are the same, more or less. Okay, so we are ready to visualize something. So we have, take the mean of we want to visualize the mean temperature for both countries for all the time span from 1950 to 2024. So we take the mean of the dimension of time in this line. We plot the climate data, the temperature data, and we plot the boundaries, so the country shape. We do it for Italy, and then we do it for Finland. And this is our visualization. So this tells us that Finland is colder than Italy. So what if we want to ask something more to our data? Maybe is the mean temperature, but a time series of what is the mean temperature through the years. So we can try to do that. We take the mean, we don't visualize the spatial data now, we want to visualize a trend. So we take the mean of the dimension of latitude and longitude. Then we calculate the annual means using X-rays resamples. And then we visualize the mean temperature for every year for both countries. So here we can see, okay, there is some year variations, so colder and warmer years, but we can see also some longer span variations that goes through all the time span. And that is what we call climate change. And now I give the words to Marina.
So the second variables that we want to analyze is, okay, I've just made a mistake with, okay. Yes, is precipitation, and a common way to measure precipitation is an index named SPEI, that means standard precipitation evapotranspiration index. And this index measures how a period is wetter or drier compared to the normal condition. Usually, negative values are associated with a drier period. Instead, positive values are associated with the wetter period. And there is a range between -2 up to 2 that is considered acceptable in some way. Instead, extreme events are outside this range. We need even to know that this SPEI index can examine the rainfall in different time scales. From 1 month to 3, 6, up to 48, and this is why the prolonged period of dryness, for example, could have a different impact according to this period that it lasts. So in this way, we need always to decide which kind of accumulation window we want to use for our analysis. The first things that we have to do is import the libraries. There are additional libraries to add to the previous one. The most important are Cartopy, that is another library to make maps. Plotly, that is a library that lets us to create interactive charts. And task for data manipulation, since we have said that this data usually has a relevant size, so we need something to help us. Where do we get the data? We get the data from the cross data store, that is another data store as the Copernicus data store we have seen for the temperature. In this case, this data store is in pre-production, so we are testing a new data set. We always take into account that the Copernicus platform is updated very frequently with new data, but this involves even attention to what we download, since sometimes we can find something that is not solved yet. But there is obviously a way to interact with the providers to have an help. So we use the same CDS API to download the data. What is important in case of the precipitation is to specify the accumulation window, the month that we want to examine. In this case, we have chosen August, since it is one of the critical months, and it is here when you see month, it is expressed in number. And the year ranges, because since as Elisa told you, the years start from 1950 up to 2025. But in this case, to not have too much data, we have limited to start from 2000 to 2025. After we have even selected the area, and in our case now we are trying to analyze the precipitation in Finland. We always take into account even the order in which we pass the coordinates to the API, since it's not always the same for all the data set. So we always pay attention to this, otherwise we could select an area that is not the one that we want. Once we have downloaded the data are downloaded as a zip file containing a list of NetCDF files. So once we have, let's see if yes, here. We have the zip here, and we need to open the zip and merge the NetCDF files. And that's why this is what this function does. Once we have merged our files, we have our complete data set named DS, and as before, with the function display, we can see in a pretty way how this data set is made. We have a 3 dimension, time, latitude, and longitude, and for each of them there are the values associated. The variable, that is SPI12, that is the accumulation windows that we have chosen, and after some information about the attributes. Now we have a series of functions that help us to clean the data. This is not required in any case, but in this case, since they are new data set that the Copernicus publish, sometimes it could help that something is not as we expect. So since we can find some data that is duplicated, or in other case, what we want to solve is not a real problem, but simply a characteristic of the data. So for example, many times you may encounter a value that is minus 9999. In this case, it means that the measure is taken in a place that is not relevant for our analysis. But when we want to create a map or a chart, we need to remove this kind of values. So that's why we have prepared some of example of the kind of cleaning that you could encounter during your analysis. In this case, for example, for Finland, I found an invalid ratio of 10%. So now we could start with the most interesting part, since we have our data set. And now we can do some analysis, and the best way to do is visualizing the data. The first thing that we could do is create a time series of values, starting from the first year up to the last one that we have chosen. And this is the function that creates the map. Where we have added an API widget, the slider, so we can find the situation in August 2000, but moving the slider, we can go on and see the data changes. What we can see on the left in the legend is what we have talked at the beginning. So the values that start from the range that is in some way acceptable between 2 and -2, and the extreme event out of them. Obviously, the normal condition is 0. So even when the values are around -2 or 2, in any case, it's a situation that needs attention. Oh, I don't know why it has replicated. Another thing that could be useful is to have a unique measures that give the situation for a year. So we have our grid with all the measures in every cell, and what we can calculate is the median and the mean, and see how they are during this period. In this function, we have created even the chance to calculate the quantiles and the minimum and the maximum. But what we will display in the chart will be just the median and the mean. So once we have calculated the statistical values, we can try to display. How can we display? In the previous case, we can rely on a color map provided from the library. In this new case, where we want to create a scatter plot, for example, we need to define our color map. So we define a dictionary defining the event extremely wet, severely wet, moderately wet, and so on, up to extremely dry. This evaluation is done by, it's an evaluation that is done and agreed between all the researchers. So what we need to do now is to assign the values that we have calculated to one of these values. And now that we have the function that creates a scatter plot, and so this is a scatter plot. Now I close again so we can see it. We can see both the median and the mean for every year from 2000 and 2025, with the color that express the level of dryness or of being wet. Last things that we could do is to combine in the year to create a stripe chart. So we use the same measure that we have calculated before. And with this, this function, the result is a stripe chart. Obviously, if you have more years, it is even more impact. It has more impact even visually. But in any case, we can see clearly which are the critical years. And so we have prepared, even if someone wants to replicate this case for Italy, but I don't see many people with the laptop, so probably there's no anyone that want to try it at present, at least. So we can say we can arrive at the conclusion. We have seen a theoretical part about climate, what is climate, the difference with weather, and which is a climate model. And after we try to analyze two kind of variables that are temperature and precipitation, accordingly to two different countries that are Finland and Italy. So with this talk, we have seen what happened in the past and even what is happened recently. But there is another talk after this one that is related to the forecast. So it's another way to go deeper in this topic if you are interested.
Perfect. Perfect. So we have a Slido. That's where you can write your questions if you would like. I see that there are none here, so in case you have some questions in real life, we can do that. Perfect.
Thanks. And I wanted to know if there are other databases that typically you use similar to Copernicus, of other geospatial data of temperature or weather data. And what is the name of the conference after this one that you were talking about?
Personally, I use some specific data by the civil protection, but just related to Italy and to specific arguments such as the snow, the level of snow. But I have to say that the most comprehensive is Copernicus, and we probably have, I'm not sure that if we had told before, but most of the data sets are free. So it's very convenient.
Yes, and I can say that exactly, we choose Copernicus because it was European data. Living in Finland, I use data from the Finnish Meteorological Institute. And about next talk is by Robin Castellani, that is sit there. The next talk about climate data. I don't remember when, but exactly. But next, is it next round of?
15 minutes.
Okay. Yes.
Perfect.
Before you said that since you have the same reference system, you didn't have to do no operation on the dataset. I'm asking in case what would you have done? There is on GeoPandas a system that makes you change from reference system, or it's you would do it manually?
Sure. There is a method. I think I have it on in the code. No, it's before. Sorry. So. Yes, it's here. So this changes coordinate system. And the coordinate system you choose depends really on the countries you want to visualize. Because, for example, Finland, that is so north, with many coordinate system, is very long, very stretched. So we have, in Finland, there is a coordinate system that we use to visualize Finland. And I guess Italy has also favorite coordinate system.
Okay, we have another question. Here.
Thanks a lot. Very interesting talk. Just a curiosity, it happened to me to work in the past with wind speed and basically wind speed data. And just a curiosity about download of the data. I remember I faced kind of some difficulties in using API from Copernicus integrated with Python. And so I ended up going into the web page and selecting the map and everything. Those are, I think, ERA 5 data. Those no. And do you use the kind of API to get the data, or you went on the web page and do it in the old way? I don't know. Just a curiosity.
Nice, thank you. Maybe you can try this microphone, might work as well.
Yes, in the first case, we downloaded the data using the API. Yes. But it's a complete data set, and after we select the countries that we are interested. In my case, I use the API, but I apply the method that you have said. So I went in a place to know the coordinates about the country, because I didn't know in advance. But it's very simple to use them, since if you go to, if you want to show the website that you show, if you go on the web page of Copernicus, there is an interface where you can select all the elements. And at the end, once you have selected everything, you find the API already created, your API request. So from this example, it's very easy to change the elements inside the parameters inside the request and adapt to your needs. Yeah.
You added the core. I show how you added the coordinates when you downloaded the data. Here, yes, here the area. So this is a way also to have not so large data set. You filter it before.
Very nice. Are there any other questions? Okay, then in this case, I would have a question. So I don't know very much about this type of data. So sorry if it's a silly question, but we saw some precipitation data and temperature data, and I was wondering what kind of data, what other kinds of data do you normally work with?
At least personally, I worked with snow depth, precipitation, humidity, wind, yes, and the historical data about that.
Yeah, me too. I'm more focused about water-related variables, also precipitation, snow, since it's a problem in Italy. And now I'm starting working with fires, because there are river index to have information about fires. But if you go always in the platform, you can find a lot of variables. Sometimes it's even difficult to know what kind of variables we should choose. But usually I interact with the researcher to define which variables. Obviously, I don't decide by myself.
Okay, thank you. And then I think my next question is just a follow-up of this. And I know the next talk is going to be about predictions, but I am curious now, what kind of insights can we get from this data that we've been talking about?
The insight depends on the area of interest and even the parameters that we have chosen. We try to set some suggestion in the notebook, so every one of us can run the code and try to find, and try to find the suggestion that we have shared. Okay.
Thank you. You have a question.
Have you ever used this data for forecasting of energy demand? No.
Very nice. Any other questions? Nice.
What is the URL for the?
Very nice. So a round of applause. This is very interesting. And